So let's find another angle problem or another geometry problem. So we have a geometry problem talking about nets. A net is like a flat version of a three-dimensional object. If we took this flat version here and folded up all of the corners, all those triangle pieces, then it would make kind of a pyramid shape. It's kind of hard to visualize in your head. But what we want to look for is usually they have markings, and we want to look for a pattern in the markings. We have circle, then a square, then another circle, then another square. So we want to try and look for the shape that has that same pattern of markings. Even if you can't see all four, you might not be able to see both circles and both squares. So it has to... Which one?
A, because it got a square in the middle, and I see a square. No, I guess more like shaped like a square, but I see a square and a circle.
Yep. And if we had a backside, they could put a square on the side behind and a circle on the side behind. So you are correct. It's answer choice A. Some things you can eliminate. Again, a good strategy is to eliminate answers that you're like, I know for sure this is not it. So like answer choice B goes circle, circle instead of circle, square. And we know that's for sure not it. Or like answer choice D shows us kind of view of top down, and it should have 4 pieces instead of 3. So we know that's not it. So then the difference between A and C, C would have to have more triangle pieces because this is just the front view. We have one triangle here, but there's also a triangle behind that square piece and a triangle behind on this side. So then we'd have to have 4 more triangles from the bottom. So we're just trying to match it up. But even if all you did was eliminate B and D, and you're like, I'm not sure if it's A or C, you still have a much better shot than if you were picking from all 4.
Right.
So this one's geometry, but it's not angles. Do you still want to, this one's about area.
Yeah.
Okay. So area, you do have some help with some of the geometry questions from the reference sheet. I always just Google OGT reference sheet math, or I think I've sent out the link before. If not, I can send it out. So when you're looking at the reference sheet, this will be, so everything's on the computer now. It's no longer paper, but this should be accessible somehow. You'll probably have to click a button to bring it up. But it has all the area formulas you might need. Parallelogram, rectangle, trapezoid, and triangle. So we're going to look at our problem and say, well, what shapes do we have? And what shapes do they want? So this one says it has a hexagon drawn inside a rectangle, and it wants the area of the hexagon. So do you know what they mean by the word hexagon?
Is it the one that looked like a, oh, that's an octagon. Like a stop sign.
Stop sign's an octagon because it has 8 sides, but hexagons kind of look similar.
Well, they got 5 sides, right?
Pentagon has 5, hexagon has 6.
Oh, okay.
So it's this kind of like diamond shape in the middle.
Okay.
And it is easy to forget all the different, but the other keyword here is inside. So even if you're not 100% sure, you could say, well, this whole shape is inside the rectangle. So that's likely what they want me to find the area of. So on our reference sheet, none of the answer choices or none of the things on the reference sheet are hexagons. They only have parallelogram, rectangle, trapezoid, triangle. None of the areas are hexagons. So sometimes they'll give you a shape where you have to break it down into its smaller shapes and find those areas because those are the only ones we know the formulas for. So what kind of shapes can you see inside the hexagon itself?
A triangle and a square.
Triangle, square. So are you looking at a triangle? Sorry, I keep having to switch back between the mouse and the... You could look at the triangle like this, or some people would look at it like this and view the whole top thing as a triangle.
Okay.
Which one were you thinking? Because both work.
The half ones.
The half one. So let's do the half one. So we have a triangle, and then below that we have a square. Everything else is some version of that. This right side, same triangle, just they moved it around a little bit. Or like the bottom, same triangle, but they flipped it.
Right.
So we really only need to focus on those two shapes and find the area of those two shapes. So the area of a triangle is 1/2 BH. So what does the letter B stand for and what does the letter H stand for?
Base and height.
Good. So when they say those words, what do they mean for the actual shape? Where is the base of the triangle?
Oh, is it the bottom?
It's the bottom. So it's this line here at the bottom. So how long is that line at the bottom? We have to get it from the picture.
Okay. Is it 3 centimeters?
Yep. So if you have two lines, even if they're separated by some space, they still start and end kind of at the same spots directly above each other. That's also 3. So our base is 3. And our height, what's the height of our triangle?
2 centimeters.
2 centimeters. It's this line going up and down. So we have 1/2 times base times height. And so they don't actually put the multiply signs here between the letter B and H or between the 1/2 and B. You have to know that when there's a number touching a letter, it's really multiply. And when there's a letter touching a letter, it's really multiply. So all of this is actually multiply. Okay. And we need to know that so that when we go to plug it in a calculator, we have stuff to type in. So we had someone join us. Right now we're talking about finding the area of this hexagon. We took the shape and we broke it into smaller parts because on the reference sheet, it doesn't even tell you an area formula for a hexagon. It tells you parallelogram, rectangle, trapezoid, and triangle. Sorry, I can't get rid of all the drawing when I switch between page and page. So we are looking currently at the area of this triangle, which was the formula 1/2 times base times height, which we now need to plug in. So again, this should be the calculator you're using now that it's all computer. Still not 100% sure. I keep trying to find out more information. So I just typed in using my keyboard 1/2. Let me show you how to do it on this keypad as well. I'm going to erase it. To do 1/2 times 3 times 2, the fraction bar is actually just the division bar. 1 divided by 2, it's going to show up as a fraction. Before we hit times 3 times 2, we do have to click to the right. It stays on the bottom with that 2. where we want it to be to the right of the fraction. And then we can hit times 3 times 2. And the calculator will pop up the answer in this bottom right corner of this top box here. So the area of this triangle is 3. Sorry, I gotta go back to the right page. This page, okay. So the area of just this triangle is a 3.
Can you hear me talking?
Yes, I can hear you. Okay. Do you have any questions about what we've done so far?
No. So you're just gonna go through and find out the area for all 6 parts?
Yes, all 6 parts of that hexagon. You could have split it differently. Some people would have split it into 3 parts instead of 6, and maybe done like the entire top triangle. Mm-hmm. But either way you pick, still gets you the correct answer. So we actually know the areas of all those triangles. All these parts are congruent to each other. They're all the same size. So if this triangle is 3, how much is this triangle?
3.
Also 3.
Right.
And then the bottom 2.
3.
Also 3. So far for our area, we have 3 plus 3 plus 3 plus 3. Got one more. So now we have to do the square part in the center. I had that in green. So the reference sheet, you can look at it and see that the area of a rectangle, because rectangle and square have the same area formula, so they don't write it twice. They're both length times width. So length times width, what is the length and the width of this square?
3 and 3.
3 and 3. Again, it matches up if a line starts and ends at the same spots directly below a line drawn in here. We know that's 3. Same thing, this left and right starts and ends at the same places. So now, how do we find the area?
Multiply them all.
Multiply. 3 times 3. So keep in mind, we have a lot written here. We're only talking about this square with one side 3, the other side 3. We're looking at just that inside piece.
So both of them be 9 on the inside.
Mm-hmm. So we have 9 here, 9 here. So now on our list, we also have plus 9 for the 2 squares. So then you can add it up in your head, or you can type it into the calculator. 3 plus 3 plus 3 plus 3 plus 9 plus 9 gives us 30. So answer choice C. You'll notice they said centimeters squared. Area is square feet because it's inside a shape, or square centimeters in this case. So it should always have that little 2 on the units. If they said area and one of these was a 3, you could immediately eliminate that answer. 3 means it's 3-dimensional, has 3 main sides, and so it's a volume instead of an area. Area is 2 main sides, like the length and the width of a rectangle. So I do have to erase all of this before we move on, since I'm using the annotation feature of this. Or do you guys need anything before I erase it all?
Nope, I got everything.
So right now, specifically, we were going to focus on some geometry. the person who joined in, it doesn't say your name since you joined in by phone. Do you have any specific topics you were also hoping to see today?
No, ma'am. Nope. I was just trying to do whatever I can get.
Okay, then we'll keep focusing on geometry. If you see a question that you're really interested in, let me know and we can stop and work on that.
Okay.
So this one is a shape, but it's on that coordinate plane, on that grid system where we can graph pictures of shapes. So it shows a trapezoid on this grid. And when it names it, it's just the corners. RSTU is just the corners of that shape. And then it says, which graph shows the image of trapezoid RSTU after it is translated 5 units up and 3 units to the left? So they use a lot of vocabulary words.
Yeah, that sounds like a lot.
Yeah, it sounds like it a lot. It's actually not as much as you think. The really important vocabulary word here is the word translated. Do you guys know at all what that might mean?
Like it's
The answer?
but it's over. It's
So
the same size and everything, and it's like.
yeah, so I think you have the general idea. It's kind of like you slide the shape around.
Right.
You're saying it moves up 5 over 3, and when you do that slide, that translation is the answer by being the shape in a new spot. So it's hard to take an entire shape and move it around. It's not easy to focus on the whole thing. When I do my translations, I focus on one point only. I'm going to focus on point T, and I'm going to compare it to all the other T's in our answer choices. You'll see the little apostrophe. That just means this is the new spot for the T. So if we take this and move it 5 up and 3 left, we're counting, but we do have to be careful how we count. When you count on the coordinate plane, you don't say the number 1 until you've actually moved a space. A lot of people will say 1, 2, 3, 4, but this dot is where we're starting. So after you've moved up 1, that's 1. And then we keep going up until we've gone 5 spaces. 3, 4, 5. So what direction now?
To the left, 3 units.
To the left, 3 units. So from that little crosshair, we're always at these points where they cross. Now we go left 3 spaces. And again, it's after we move. So here we don't say anything, but when we get to here, that's 1 space, 2 spaces, 3 spaces. So this is where our T should end up, and that's the only one we're going to focus on. So from the answer choices we can see, does one of them match?
We can't see all of them.
I can't see C or D.
Okay, let me scroll down. Oh, gotta change the setting. So now we can see all 4. The problem is we can't see the main picture anymore. But if you remember, we ended up right here. It was on the y-axis at the 6.
I would
So
say
it's an A.
Okay, so one person said A. What was the other answer choice?
C.
C is in cat.
Yes.
Okay, don't get confused. Let me clear all the annotations. Something I drew is showing up on C. Now, without all the annotations gone, we were looking for the dot of T. So each of these have a T. We want the T to be at the 6 on the y-axis. So I think the blue dot I had drawn was making C look like it had a dot at 6. But that's just because the online program's a little wonky. So answer choice A is correct. Let's see if we can find another geometry problem.
So if we have a question like that for like a multiple for multiple points, you know, because there's 4 options. So would it be okay if we would have picked any letter besides T? Like, 'cause, you know, like how would we know like which letter to graph off of?
So if it was one where you had to do the movement yourself, you have to do all 4. That's a good question. So let's say this was, instead of A, B, C, D, it just said, I want you to translate this shape and draw the final picture. So you'd have to move T up 5 over 3 and get the new spot for T. Then you'd have to go over to S and do the same thing. Count up 5 spaces, 2, 3, 4, 5, over 3. And if you want to actually draw the line, you can. You don't have to. I draw it in so you guys can see what I'm thinking as I'm counting. I went up 5 spaces, left 3. That's your new S. Then you'd have to go down to R and go up 1, 2, 3, 4, 5 spaces, left 3. And you'd have to do it one more time and do it for U and go up 5 spaces, 4, 5, and left 3. So when you hit an axis, we're about to hit the y-axis, that still counts as a spot. One spot to go over to the y-axis, then one more to go past, then one more to make it here. So you'd have to do all 4 and then connect them to make a shape.
Oh, I see. So that basically would be like doing it all over again. But how, so how would it be questioned if it wanted you to do all 4?
So the only reason we didn't do all 4 is because they had answer choices for us to look at. So the question would be pretty similar. It would say, draw the image of trapezoid RSTU after it'd have most of this same, but instead of saying which graph shows, it would say, do the work yourself, draw it out.
Oh, okay. And then you can go to the answers. Could you scroll down a little bit?
So if this were you drawing it out, they wouldn't have these. If it said to draw it and you had multiple points for this question, you wouldn't have any answer choices. It would say, show the work.
On the graph, like they give you on the other page to do.
Yep, yeah.
That's why I think I keep flunking it, because I keep skipping them.
Yeah. Those problems, you want to try them, even if you feel uncomfortable with them. It's possible that usually you know more than you think you do. And when you try them, usually you'll get at least part of it right. And they give partial points for those. So still try them, even if you're like, I'm not 100% sure. The more you have written down, the more likely it is you'll get at least a point or 2 points out of, the 3 or 4.
Right. Wow. Could you scroll up just a little bit so I can see the answers?
Yep.
Please.
I'm going to go ahead and erase my writing so you can see them. So if it's multiple choice like this, you just have to select one. You don't have to do each point unless after doing 1 point, maybe you're like, I'm still not sure. You could do all 4 and double check.
Basically, you get the same answer for every point.
Yep.
Okay.
So answer choice A worked for all 4 points. We just only picked one to save some time and to not make it as complicated.
Wow.
Right. Okay. Alrighty.
Okay. So let's look for another geometry problem. So this is the 2009 OGT No, that's not right. So their website only has like 5 practice tests, and this is one of them.
Okay.
Okay, so here's another geometry one. Points Q, R, and W are plotted on the coordinate grid. Which should, or where should point Z be plotted so that parallelogram QRWZ is formed? So when it says the word parallelogram, what does a parallelogram look like?
A cross. Will it be a point B? I mean, is that R or? Okay, let me see.
There is no pyramid. I don't know what that looks like. Those shapes are hard. There's all type of different shapes. I don't know what the heck they look like.
There are a lot of different shapes. Sorry, I was trying to zoom in. Okay, can you see it a little bit better now?
Mm-hmm.
Okay. So a parallelogram has the word parallel in it. Do you guys know what parallel means?
Right. Don't that mean like a cross or, you know what I mean? Like a cross?
Across
Yeah,
from
like
each other.
cross. Yeah.
The 2 L's are actually parallel to each other. They're kind of across from each other, going the same direction. And that's how I remember what parallel means. So a parallelogram is made up of parallel lines. It kind of looks like a tilted rectangle.
Right.
And you can see that like this top line and this bottom line, those are like the 2 L's in parallelogram. They're across from each other, going the same direction. Or the left and the right, those are across from each other, going in the same direction. They're parallel, made up of just a whole bunch of parallel lines.
Do they have a reference sheet for that or no?
No. Knowing what the shapes are is up to you. So so my writing will not be on the reference sheet. On the reference sheet, they have the formulas, but they don't have the pictures. So you do have to know what each of these shapes mean. You have to know parallelogram, rectangle, trapezoid, triangle, and then the volumes, the cone, cylinder, pyramid, rectangular prism, right prism, and sphere. So the ones I'm sure you're familiar with are rectangle and triangle. Those ones are used so much that they probably stuck in your brain. And your triangle could be like a right triangle, or it could be a little bit bigger. We know a triangle has 3 sides. You can tell from the word tri in it, like a tricycle has 3 wheels. Triangle has 3 sides. So rectangle, we know, looks like this. Parallelogram is that tilted rectangle. And I remember it by being made up of a whole bunch of parallel lines. Trapezoid looks like this. I don't know a great way to remember it, but it has a set of parallel lines, and then the other 2 lines are doing whatever. A cone is like an ice cream cone. Sometimes they'll have it upside down though, so like the flat part is down and the pointy part is up. But I remember it like an ice cream cone. A cylinder is kind of like a toilet paper tube. When you run out of toilet paper, it's just that round brown tube. A pyramid looks like an Egyptian pyramid. So with this 3-dimensional one, there's stuff behind that you can't really draw out. So when I do the dotted lines, that means this is behind what we're trying to see up on the front. Rectangular prism, that is a fancy name for a box. Yep. And again, it has some dotted lines behind to show the three-dimensional part of it. A right prism can be another shape. So a right prism could be like a triangle. Where it then gets extended out, kind of like the box. If we extended this rectangle back, or sorry, the square, the front square, we extended it back behind, that's where we're getting the length. If we took that triangle and extended it back behind, we get some length. And then a sphere is like a basketball or a baseball. Or a globe. So those things you have to have memorized. You have to know a cone looks like this, a cylinder looks like this. Sometimes they'll say the word cone or cylinder so you can look, but sometimes maybe they'll give you a picture. You have to go look and say, oh, this picture is a pyramid, so this is the formula I would use.
Okay.
Okay, so I'm going to go back to the problem now. And I'm going to erase everything I drew so that it doesn't muddy up the problem. So we want a tilted rectangle. A parallelogram is the tilted rectangle. So right now we have Q to R. That was not very straight. Let me try again. And R to W. So they're saying, where do we put the last point so we get that tilted rectangle made up of parallel lines?
Will it be
Using
4 and 2?
Would it be 4? Oh, sorry.
We have two answers at once. So who wants to go first?
I think, oh, go ahead. I was thinking 4 and -5 or -4.
So like down here.
Yeah.
Okay, so if that's our point and we connect the dots. Sorry, it's really hard to connect a straight line with a mouse. Does this look like it's made up of parallel lines?
No.
No. So not a parallelogram. Almost looks like a trapezoid, but not a parallelogram. So then, second answer, what do you think?
I think, is it 4 and -4?
So that's where we were just at. If you go to 4 and then down to -4, that's a little bit too wide. We want our shape to be parallel. If I drew a line that's going in this direction,
okay. So it should be -4.
We're going to be going that way, and we're going to be going kind of this way.
Row.
So 3.
So somewhere around here. So probably
it'd be 1 and -3.
Probably -3 and -1. Probably like right there.
Mm-hmm.
But let's look at our answer choices and see what options they give us.
So we was going out too far.
Yep. Yep. So we have 2 -6, -1, -3.
I think it's B.
I think you are correct.
-1, -3. Okay, so we don't have to go out that far. It's smaller than that.
Yep.
Yeah. Okay, I get it now.
Right.
Yep. Yep. So what you could also do, though, is you could try your answer choices. If you're like, and you'll be able to see the whole thing instead of having to scroll back and forth. But you could try and say, okay, -2, -6. I'm going to draw this in pink. If I go left 2 and down 6 to -2, -6. So that was just counting to tell us we put a point there. Let me just draw in the point now.
Let's see if it looks right.
Yep, then I connect the lines and say, does this look like a parallelogram? And one side kind of does, the left and the right.
The left is right, but not the pointy.
But not the pointy top and bottom parts, so it doesn't work. And then we try our -1, -3. We'll be like, oh, that looks like a parallelogram. It's probably that. And you could also try the other ones just to be sure, you know, kind of do that process of elimination again and see, is there anything else that's kind of close?
Good idea.
Okay.
My name is Michelle, by the way.
Thanks. And I've been afraid to say our other student's name because I'm afraid of saying it wrong.
Naisha.
Naisha. Okay, Naisha and Michelle. Sorry, I have to switch back and forth between the mouse and the drawing thing, so sometimes it takes me a second to figure out which one I need. Okay, so this one doesn't look like it's geometry because they don't give us a picture, but sometimes in the middle of the problem, you'll say, oh, that's an actual shape. Like this one, a manufacturer wants to make a rectangular storage box. You got that word rectangular, that's geometry. With volume 0.75 cubic meters. So volume is this, length is 1.5 meters, and width is 0.4. What is the height of the box? So now we have to know, okay, rectangular storage box, which one of these things on the reference sheet, and ignore the underlined brown stuff, that was from the previous page. So which one of these was our box? I said one of those is just a fancy word for a box.
That was the prism, the rectangular prism.
Rectangular prism. So the formula says V equals LWH. We also have to know, what do those letters actually stand for? So V stands for volume, and it's on our list. So that one is easy to remember. What do you think L, W, and H stand for?
Length times width.
Length, width, and?
What's the other letter?
Naisha, I think I didn't hear what you said.
I didn't hear what you said. I heard L and W. I didn't know it was another letter.
L, W, and H. It's on the right side of the screen, so maybe you can't see that far depending on your screen size. Yeah. But LWH is length times width times height.
Right.
Let's go back to our problem page. So we just had Ray join. Ray, we're talking about geometry problems today. And focusing on, you know, how do we use that reference sheet? What does each part of the reference sheet mean? So we know now that the rectangular storage box, that was the same thing as the rectangular prism. And we have the formula, that's length times width times height. So we look at what they gave us. Which of these letters do we know from the question?
The volume.
Okay, we know V. What else?
An L.
The width.
The width and the length. We know L is 1.5. And width is 0.4. The number we do not know is the height, so we leave that as the H. Lots of dots. The ones that are lower are the decimal point. The ones that are higher, that's our multiplication symbol.
Oh, do you got the headphones?
So we could try and solve this, or again, we can use our answer choices.
You gonna bring them tomorrow? Okay. Oh, sorry, guys.
It's okay. So with multiple choice, it's really good to try the answer choices instead of maybe having to go through the solving process. So like we can try answer choice A as the height. We can try 1.5 times 0.4 times 0.15. So we're just trying answer choice A, seeing if this is going to give us the correct volume of 0.75. So we go to our calculator and type it in. 7.5 times 0.4 times 0.15. And I just typed it on the keyboard. And it says in the corner 0.09. Is that the number we wanted for the volume?
No.
Nope. Volume was 0.75. So answer choice A is not our answer.
So because it's asking for the height of the box, that will make the whole box complete.
Mm-hmm.
So you're trying to figure out what the volume is, because the volume is the whole thing.
Mm-hmm.
So you just plug in the answer, the options, until you get to 0.75.
Correct. Exactly.
Mm-hmm.
And so when the formula said LWH, they didn't write the multiply symbols. It didn't specify. When there's a letter next to a letter, that's why I wrote multiply. L is next to W, it's multiply. So that's why we're doing multiply. 1.5 times the 0.4 times. Now we're going to try 0.45.
Okay.
And with decimals, that's really hard to draw out. It's really hard to do by hand. So it's better to just use a calculator. They should provide one. I'm pretty sure it's this specific calculator.
It's the one that you're using all the time?
Yes, I'm pretty sure. They've made a lot of changes lately. So that's what I think I figured out. It's been hard to find the correct resources because they're switching over and not using this as much for the newer students.
Oh, okay.
But I'm pretty sure this is the one you'll have access to. So that says 0.27 for our answer.
That's not right.
That's not right either. So the process of elimination can be kind of
time consuming.
That's not it either. Yeah. There's 1.25. We can't hear you unless I did something.
I know. Did I do something? Oh no, I can hear you.
Yeah, I can't hear her.
Me either. So she must have did all of them, and that was the last one.
Okay, yeah. Nope. That was, somehow I muted myself. I didn't mean to mute myself. Sorry.
Okay.
Just took me a minute to figure out what had happened. Okay. And you guys can still see my screen?
Yes.
Yeah.
Okay. So if you're unsure, you're like, I'm not sure I did that correct, you could still try D. You could still do the last one and say 1.5 times 0.4 times 1.25 and be like, okay, yes, I got the right answer. But if you're confident, you don't necessarily have to write out the work for D as well.
You making this seem so easy, and then if it was right in front of my face, I'd be like, oh, I do this.
Some of it is just
that's exactly my thoughts.
Some of it is just the panic. You kind of panic and you forget some stuff you actually do know.
Right.
I need some medication.
I think the process of elimination is really important.
It is. It is very important. That can really help on these multiple choice type questions.
Right.
Okay, so, nope, actually that's not geometry. I thought that one was geometry, but it's not. That's not geometry. Here's another geometry. Similar trapezoids are shown. So we talked about trapezoids being the name of this kind of shape. The top and bottom lines are parallel. The other two lines kind of do whatever they want.
I'll ask if you want to help.
So what is the value of n?
Value of n. What is the value of
The
n?
value of n. So what's the number for n? The length.
Yep, the length of this line n. So this one is kind of tricky. Again, we can kind of use process of elimination just by looking at the picture. What does n look like it could be from our possible answer choices?
10.
Okay, 10 is a little bit bigger than 9, so it might be 10. Which other one could it be?
19.
So 19 is it's more than twice of 9. 19 is
yeah, that'd be
twice
too much,
as big.
right?
That'd be really, really big. So we can definitely eliminate 19 because it's just
And 15, really.
Yeah,
probably not 15.
yeah.
No?
This one maybe, but you're right. It's probably not 15. If I was eliminating just by the picture, I'd go with you and say not 15, most likely.
And see, I didn't even realize that the 9 was up there on top to go off of.
Yes. Yep, you want to look for all the parts of the picture.
So will we subtract 120 from 60?
This one's even trickier than that. This is why I'm doing the process of elimination. And then I'll go through the longer process. But this one, I would actually suggest process of elimination. So between 10 and 12, 10 would be just like a teensy bigger than 9, and 12 would be a couple bigger than 9. So does that bottom line look just a little teensy bigger than 9 or a couple bigger?
But I had to take the RGT test.
I'll take 12.
Like I was in high school again. No.
So I would say this is probably 12 just by looking at the picture, because it's a little bit bigger than 9,
definitely.
but not too much bigger than 9.
Right.
So to do this problem the long way is really, really complicated. There's a couple of things you have to know about geometry. The first is what this word similar means.
High school.
Similar means it's been made bigger by the same amount. You're multiplying by some number. So like 6 multiplied by something gave you that number 9 at the top. So we could actually figure out the number here on the side that matches up with the 4. So to use similar shapes, you set up what's called a proportion. I'm going to write it inside this bigger trapezoid. So we have this 6 that's the top of the trapezoid on the left. I'm going to call it left top. And the 4, which is the right of the left trapezoid, left trap, top of the left trapezoid. This is the left trapezoid, but it's the right side of the left. And then the 9 is in the same, this is the top still, but it's of the right trapezoid. I'm going to say RT for right trapezoid. And then this side we don't know matches up. It's the right side of the right trapezoid. We can actually find this by setting up a fraction. We just have to keep it in order. I almost just like draw the division bar between the two things. So it'd be 6 over 4 and 9 over x. You just have to keep it in order. We went top, right. Top number, right number. Then we did top, right again. Top number, right number. Does that make sense so far?
Yes.
Okay. So once we set up our trapezoid, oh, I just saw the group chat. Ray also thought it was B. You are correct. B is the most likely just by process of elimination.
No.
If we're doing it the long way, we set this up, we solve for x by cross multiplying. We set up this proportion, we do 6 times x and 4 times 9. Anytime you have these two fractions, you can cross multiply. So 4 times 9 is 36. And then we do opposites. Opposite of multiplying by 6 is divide. Like I said, doing it the long way actually takes quite a while.
Oh, okay, but it's good to know, because
Yeah. Yeah, what if two answers were too close to just tell?
Right.
You could still eliminate and have a pretty good guess, but you can also go through this process. We figured out that right side now is 6. We do that. I'm going to have to erase some stuff because I have too much written down. So let me get to the right place where I can erase it. Okay, so we did all that work. We set up our trapezoid, or our proportion, and we got that this was a 6. So with a trapezoid, if we draw in one extra line, we can split this into 2 shapes we know. A rectangle and a triangle. So on a rectangle, we said if we know this top line all the way across is 9, the matching up line on the bottom is the same amount. We finish at the same spot, basically, right above and below each other. This part is 9. The rest is part of that triangle, right here. So we actually have something on our reference sheet that we can use when we have a 60-degree angle and a 90-degree angle in a triangle. The 120 is actually useless to us. We don't care about it. So when we go to our reference sheet, at the very bottom, you have these 2 pictures that are triangles. One's a 45, 45, 90, and one's a 30, 60, 90. And since we have a 60-degree and a 90-degree angle, this is the triangle we want. So I'm going to draw this back on the problem page so that we can see it. So we had 30, 60, x. I'm going to have to go back because I don't remember the other 2. 2x and x square root 3. So like I said, the longer process is a lot longer. 2x, x square root 3. So when we look at these 2 triangles, we're comparing them to each other, and we're looking at the side we know versus the side we want. On the triangle here, on the trapezoid, what side do we know? We went through that proportion process to find it. On this triangle, what side do we have an actual number for?
On what side? I'm sorry.
What side is there an actual number for? This left side that's kind of long, this bottom side kind of short, or this tilted side?
We actually have a number is the top side. Oh.
The top side's not part of the triangle, though. We do know that 9, but that's,
okay.
yeah, the triangle piece only.
Is it the 4?
The 4 would be for the smaller shape, but we don't need the smaller shape because we're looking for the n on the bigger shape.
Oh.
But we found a number. I had it written over here. Can you? I'm not sure. Yep, the 6 on the far right. We know that number. That tilted side matches up with the tilted side. I call this the formula triangle. They call it a special 30, 60, 90 triangle. So we want to match up this 2 times x matches with the 6. They're both the tilted side of these triangles. The reason that's important is because if you have 2 times x equals 6, how do you solve for x on that? What opposite would we do? If we have 2 times x equals 6, what opposite?
We divide.
We divide by 2. So 6 divided by 2 means x equals 3. So the side we want is the short side. We wanted this red line here because we know part of this is 9, but we didn't know that ending part. Well, on the formula triangle, the shortest side is down here. It is the letter x, which we just found. We said, well, we now know the letter x is a 3. So this little line is a 3. So if you have 2 pieces, we know 1 piece is 9, 1 piece is 3. 9 plus 3
equals 12.
Equals 12.
Yeah, that's doing a lot.
It is. You had to do proportions. You had to do special right triangles. You had to add 2 pieces together. That's why this particular type of problem, to me, it seemed easier to look at the picture and kind of estimate, because there's so many processes. And some of those questions on the OGT, they like doing that. They like giving you, well, do this first, then do this. Let's see if we have time for one more. If I can find another good geometry type question. So here's one more geometry question. Michelle is planting tulip bulbs in a rectangular planter with the dimensions shown. The rectangular planter is a key word there. Michelle plans to fill 3/4 of the planter with soil. How much soil will Michelle need? Or Mitchell, sorry, Mitchell. So, rectangular planter, again, when we go to our formula sheet, we have to know, and let me scroll back up, which one of these words mean rectangular planter?
Area, would it be left times width?
So that would be area. The rectangular planter, we're trying to fill a 3-dimensional object, so we're working with volume. So even though rectangle is a key word for area, we're looking for the word rectangular. Slight difference, but it gives us 2 different formulas.
Carl says, please don't date him.
So which one?
Which one says the word rectangular on this formula sheet?
Is it rectangle?
The rectangular prism?
Rectangular prism. So even though it calls it, yep, Ray also got it, rectangular prism. So even though it called it a rectangular planter, it still had the word rectangular, which gives us the formula, length times width
Rectangular
times height.
Did you already do this problem?
We just barely started it. We did a problem before that was rectangular prism, but it asked it a slightly different way. The last one gave us a volume, and we had to try each answer choice of the height. This time they gave us a length, a width, and a height.
Okay.
So this time we have to find the volume ourselves. So what do we do with that 8, 9, and 22 to find the volume?
Multiply.
Multiply. Length times width times height. So we go to our calculator. Oh, I'm going to close out some of this other stuff. Do 8 times 9 times 22, which is 1,584. Now, if you're not careful, you would think you know the answer right now.
Right, because it's there.
It's
So
there.
this is 3/4.
Yep, but it's 3/4, so it's less than that. Now, right now, there's only one answer choice less than that. The last one, which we can't see, is bigger. So we know it has to be A.
A.
But again, what if they have 2 answer choices? So when it says only fill 3/4 of the way, you can multiply by that fraction. We do the answer we just got, 1584, multiplied by 3 divided by 4. Multiplying by that fraction gives us the exact volume of 3/4 of the planter. Okay. So be careful, because that's another thing to watch out for. They love giving you a problem where you get an answer. You're like, I see the answer. That's the correct answer. But there's actually an extra step that you have to do before you have the final answer. So always make sure to read through and you say, well, how much soil if it's only 3/4 full? Make sure you're answering what they want you to find. So we are out of time for today. We're going to do this again probably same time next week, probably 5 o'clock again. If not, I'll send a message letting you know if it's going to be, sometimes it has to be 5:30 depending on how the other teachers' schedules are going. And if you are confused about when you're taking the actual OGT, you would want to contact Amy Wright. She is in charge of where you're going. Her email address is amy.wright. She's the one who sends you all the fill out this form so that you know what testing center to go to. amy.wright@graduationalliance.com. Graduation. You should have her email address because she should have been sending you stuff.
Right. Yeah, I have it.
Okay.
I have it too.
Good. So if you have any questions about when you're testing, if you forgot, you don't remember anymore, she can answer all that for you.
Okay. Thank you.
You're welcome. Have a great day, and I will talk to you guys next week.
All right.
Okay, thank you. You too.
Bye.
Bye.